Konnichiwa. My name is Edgard Capdevielle, as I was introduced. I am the CEO of Nozomi Networks. It is a true pleasure to be here. Thank you very much for having me. And today I'm going to talk a little bit about why do we need real-time visibility and cybersecurity for industrial control networks. There are several market trends associated with digitization, with getting more out of your current systems, getting information out, making a lot more intelligent decisions. And this trend is primarily called IIoT convergence, where you start adopting more standardized technologies in your OT environment for the sake of innovation, modernization, and again, making more out of the information that you have in the plant. So that's one main trend. Another main trend is the requirement of resilience and uptime. More and more do we require that our factories, our plants have the highest utilization and the highest uptime. Safety, of course, continues to be paramount. Safety as well as process systems continue to be more and more automated over time. There is a lot of pressure, competitive pressure, to have proprietary and confidential information about how things are made protected. Cyber espionage is a big problem, specifically in the manufacturing area. And of course, we all need to protect our reputation at risk, not only violations of privacy, but getting hacked or having downtime can get anybody in the newspapers these days. And then last but not least, we have a lot of nation-state activity threatening our cybersecurity and our critical infrastructure. There has been a ever-increasing number of attacks. The industry of industrial cybersecurity was put in the map in 2010, 8 years ago, by Stuxnet. Stuxnet basically was a big, famous attack into Iranian facilities and basically gave birth to cybersecurity. Since then, we have had an increasing number of attacks, increasing types of attacks that have impacted critical infrastructure. Since Stuxnet, we've had the power outages that were inflicted in the Ukraine by Russia. This was very unfortunate, taking the power down during a very critical period of time. The winter in the Ukraine affected a lot of people. We've had a lot of cyber espionage, ransomware affect various facilities. Specifically, crash override and WannaCry made significant impact, locking critical infrastructure. Specifically, when you lock all the Windows machines of a power plant or a chemical plant, that plant has to go down, even though you haven't really affected the OT systems. And then last but not least, we have probably the most important effect or impact that our industry has had, which is the Triton malware. The Triton malware happened earlier this year and is of extreme importance for two reasons. Number one, it was directly targeted towards the safety systems. Everybody who's familiar with industrial controls know that you have industrial controls to control your plants, and then the safety system is the system of last resort. It's the one that's supposed to safely shut down the plant and save people. And that's the system that got attacked. So that's the number one issue with Triton. The second issue with Triton is that it was a malware not targeted at Windows machines. All the malware that we've had so far has been targeted to Windows machines. Triton combined attacking Windows machines with infecting PLCs. So the malware acted and lived on PLCs, which is for the first time that we have seen this. This shows a tremendous amount of intention and a tremendous amount of sophistication in evildoers around the world. So, I think we have a lot of pressure for us to implement industrial cybersecurity. I'm going to use 3 use cases of 3 customers or partners of my company, Nozomi Networks, to show how we implement industrial cybersecurity in 3 different ways. The first one is a dear customer of ours, Vermont Electric. If you were here earlier, you would have seen the video that was playing on the screen. That video was of Chris Smith. Chris Smith is the plant manager at Vermont Electric. Vermont Electric is an electric utility serving a portion of the state of Vermont. One of the main concerns initially was, oh my God, I'm going to have to manage one more tool. One of the things that you'll see in the video is that Chris was able to save a tremendous amount of time and basically get 20% of his time back after he implemented Nozomi. One of his main challenges, as you can see here, was to have visibility into his industrial control network. Normally, when you want to have visibility, you have 2 really bad options, and this is the standard approach. One option to have visibility is to do it manually. You have to collect information manually, look at old documents, interview people, go to all parts of the network to try to understand what is going on. That's very manual and time-consuming. And then the other option is to use an active network solution. An active network solution would immediately flood your networks with a lot of packets to try to map and get visibility in your network. Anybody who's worked in OT understands that active solutions in the network are not allowed, right? If you don't want to disrupt the behavior of your network or the behavior of your operations and introduce risk. So you basically have 2 really bad options and you end up doing it manually. The better approach is to have passive auto-discovery. Automatically and passively map your network and have a list of basically have full visibility. This is the visibility that people have normally on an industrial control network. Industrial control networks basically have no instrumentation. It's very hard to have a real map representation of your industrial control network. So the new approach, instead of having a manual process, is to introduce an appliance that can automatically map and discover the network. You can automatically map and discover IT devices. You can automatically discover OT devices. You can create a list of those devices. And you can track the features or the firmware or the vendor, all the attributes of those devices. You want to do that automatically. You want to do that in real time. And you want to do that passively. Usually, this is the #1 problem that we have. We show up to a plant or to a factory, and people don't know how many PLCs they have. PLCs are being moved around. Nobody knows what firmware version they have. Who was the last person who changed a configuration file? So having real-time visibility is super important. You cannot protect what you can't see. We do all this via our passive auto-discovery functionality that is enabled by artificial intelligence. So in this case, one of the things that Vermont Electric was able to do was connect our appliance to their network. Immediately, all the nodes in the network appeared. Initially, they had a very flat and busy network. Our product allowed them to do smarter segmentation. Once you have the map of your network, you're able to drill down and understand the relationship between the different nodes in your network. You're able to see who is a SCADA master, who is a PLC and a slave, what protocols are being used. You can actually go deep into the details of the network. You can find out a lot more about a node, what type of protocol it's using, how many packets has it sent, how many nodes is it connected to. Does it have the role of a SCADA master, the role of a PLC, and so forth. You can also find more information about the variables that are being managed or monitored by that PLC. This variable may represent water pressure or the speed of oil in a pipeline or something like that. These are process level variables that can be monitored with the product. You can go deep into link information. You want to know packet sends, packet received, level of packet retransmission, for example. You can go into the contents of the files being sent across the network, whether the SMB protocol is being used, and so forth. You can also evaluate the persistency of links, making sure that links to particular substations are staying up and solid. One of the most important parts is to evaluate public connections. We go to many plants, and they believe that their plants are isolated or air-gapped. And that's just not true. We're able to show them very quickly that there are unsanctioned ways in which the network is connected to additional networks. It doesn't have to be to the outside internet, but to networks that they were not expected to be connected. And not only you get to do this the first time, but you need to evaluate this on an ongoing basis. That was the use case of visibility. I'm going to move on to another use case. This other use case is asset inventory. Again, people tend to not know how many PLCs they have or what firmware that PLC is running on. This particular case study is in another one of our customers, Enel. Enel is the 5th largest utility in the world. They started in Italy, in Rome. They served that country well, and then they expanded outside. They now serve Spain. They serve the United States. They save pretty much every country in South America. They're very large. And they monitor and protect 500 hydro generation facilities with the Nozomi technology. And as you can see here, we have many types of users. We have cybersecurity users that care very much about our product because of the cybersecurity value. But you also have OT users. In this case, OT means hydro generation. So the head of hydro generation also wants to know about network assets and network asset inventory. So in asset inventory, you also have bad options. You either collect asset information manually, you go PLC by PLC checking, or you can check actually over the network. Very few networks have a one particular solution or vendor, so they have to go into every console to check every single PLC for firmware version, for hardware extensions, and so forth. By the time you're done, your network has changed. Something has been updated, and it's not accurate anymore. So again, we propose a much better approach to have this done in real time, in an automated way, and in a passive way, without any disruption to the network or any disruption into the process. So for example, this is a list of automatically detected assets. You can see that you detect IT assets, and you can automatically detect the operating system of that particular IT asset. You can detect OT assets, and you can detect the firmware version of those OT assets. You can detect vendor information, product types, serial numbers. And if you dive deep or double click into particular assets, you get to see very intimate details of that asset. So for example, some PLCs are very big. They have multiple slots. So you can see that some of these PLCs have extra hardware components, and those extra hardware components, for example, connectivity cards, may have additional software running in it. As I mentioned at the beginning, the evildoers have moved on from just IT devices. They're now attacking firmware devices that is embedded into PLCs. So it's extremely important, more than ever, to monitor all the software, not just the software sitting on Windows. Also very important is to tie the asset information with publicly available information around vulnerabilities. We search information, vulnerability information, from many places around the world, including the National Vulnerability Database, which is managed by ICS CERT, has the latest vulnerabilities associated with OT. And we, for the first time, allow operators to do risk management on the OT side. Everybody is very familiar with risk management on the IT side. You know your vulnerabilities, you know their criticality, you rank them, and you tackle them at your own pace, at your own discretion. In OT, that was not possible because it's very, very hard to collect asset information and to tie that information to available vulnerability information. You can organize your assets in many ways, in this case by the Purdue model layers, and so forth. I'm going to move on now to the third use case. This particular use case goes beyond visibility, beyond asset inventory, and goes straight up into cybersecurity. FireEye is not a customer of Nozomi, it's a partner of Nozomi. FireEye, as you may know, it's a very well-known cybersecurity vendor, very sophisticated. They offer a managed service for IT. So if you have an IT infrastructure, you can have FireEye manage your cybersecurity. They were looking to extend their managed services into OT, and they made a very public RFP to everybody that provided cybersecurity services for OT. Thankfully, it was an honor for Nozomi to participate in their RFP, and it was an honor for Nozomi to win that RFP. So FireEye selected Nozomi. Every time FireEye does OT managed services, they do it with Nozomi Networks. The standard approach for cybersecurity is actually very archaic. It has to do with network isolation. Network isolation is a myth. It does not work. It worked in the past when OT network technology was not compatible with IT network technology. By design, isolation worked. Between 7 years ago and 10 years ago, OT networking technology moved to TCP/IP. Once you move to TCP/IP, network isolation does not work. That is just a reality. So the only industries that can really have the discipline to enforce network isolation are very few, mostly military and nuclear. Traditional industries do not have the discipline to keep networks isolated. So it's not good, it's very detrimental to believe or to rely on network isolation. So the new forms of protection require constant cybersecurity monitoring, real-time cybersecurity monitoring, and cybersecurity monitoring that is not going to harm the process that is being monitored. One best practice for cybersecurity monitoring is to combine two worlds. There are two worlds in cybersecurity. One has to do with artificial intelligence, and we apply artificial intelligence and machine learning techniques to learn the behavior of a system. So we call that anomaly detection or behavior-based anomaly detection. Usually you have one class of system that does that. There's another class of system that does signature-based or rule-based detection, like firewalls, for example, in IT. And the best practice now in the IT side of the house is to combine and correlate both methods. AI-based anomaly detection with rule-based anomaly detection. And that's what Nozomi does to provide a much more accurate detection of infections, threats, vulnerabilities, and so forth. Our Dynamic learning technology, as I mentioned earlier, uses artificial intelligence to learn about the process that is going on. We create a machine-level model of the physical process that is being run in this particular industrial control network. So we know the baseline, we know what's normal, and we're able to detect what is abnormal. It may be an abnormal connection. It may be change in cyclicality of a particular variable that is a process anomaly. It may be cyber-generated. It may be generated by machineware. It may be generated by human error. Regardless, it's affecting your uptime. So you want to know about all the anomalies. Therefore, you want a system that allows you to monitor, detect, and secure your industrial control network. You want to be able to have real-time cybersecurity for a particular plant, a particular location. But unfortunately, we cannot have cybersecurity professionals everywhere, in every one of our plants. We need a way of centralizing and distributing all this information at the same time. So we have to be able to aggregate all this information into a central security operations center to be analyzed. And you also want to allow a centralized security operations center to remote access all your facilities around the world for threat hunting capabilities. The Nozomi system is multi-tenant. It allows shared infrastructure to monitor multiple plants. And for example, NL is able to monitor their global facilities around the globe through the same infrastructure. NL has plants in Brazil, in Colombia, in Mexico, of course in Italy. Italy is where they have their SOC, their Security Operations Center, and they're able to monitor all this activity, whether it's visibility, whether it's asset information, or cybersecurity, from a central location. Let's go through one example. This is a particular incident that was detected with our platform. We call this an incident. An incident is a grouping of alerts or a grouping of actions. And we always report the incident as well as the components of that incident. Here in this particular incident, you can see that there are several steps that we're taking. First of all, there was a new MAC address published. That's a telltale sign for network spoofing. Then there was a new protocol detected. Then somebody tried to reprogram a PLC during a production run. So clearly this is extremely dangerous, and you want to be able to monitor, to detect it, and to protect against it. You can also generate traffic for forensic analysis. There's many things you can also do. You can monitor communication between nodes. For example, the SMB protocol is a protocol that you must absolutely monitor. This is how you send files across your different nodes. And you may find that in that SMB traffic, there may be some malware being sent. In this case, I don't think you can see it, but in this case, we have WannaCry capture going from one node to another. This could potentially bring down your operations. So, my 3 use cases show that you want a solution that can passively and automatically provide visibility, provide asset inventory and cybersecurity, and scale to a large number of nodes. To scale to cover all your plants and locations around the world. So with that, I would like to introduce my company, Nozomi Networks. Nozomi Networks has been around for 5 years. We're a young, growing company. We now have more than 1,000 customer installations. We monitor and protect over 250,000 industrial devices. We have implementations around the globe with global support. We now have 8 offices around the world. I forgot to add Rio de Janeiro. And some of my colleagues here are from the Sydney office. I am based out of San Francisco. Most of our engineering is based out of Europe, in Switzerland. So we can support customers around the globe. And we serve all the industries that use industrial control networks as the main support system for their production of revenue. If your industrial control network is important to you, then you can be a customer of Nozomi. We support power, electric utilities, we support oil and gas, manufacturing is a very large vertical for Nozomi. And one of the differences about Nozomi is that we work really, really hard to make our customers successful. And therefore, we have a large number of customers that is happy and willing publicly to speak about Nozomi and their success. So for example, I've already talked about Vermont Electric, which created a video for us. I've talked about Enel, which created a case study for us. Let me talk about Senegas. Senegas is the gas distribution company of Mexico. If you receive natural gas in the country of Mexico, that network of substations is protected by Nozomi Networks. Another customer is DIWA. DIWA is the primary electricity generation and electricity distribution of the city of Dubai. Very much like Tokyo, Dubai is preparing for Dubai 2020, which is the expo. They are convinced that they're going to get attacked during the expo. Everybody wants the world to see lights coming down during the expo. So DIWA decided to protect their distribution network for electricity with Nozomi Networks. These are a few of our customers. So just to conclude as a summary, Nozomi Networks provides a solution where you can achieve 100% visibility. Visibility is the number one step. It's the most important step. You cannot protect what you cannot see. Number two, you want to create a list of assets. You want to be able to provide cybersecurity. You want to be able to troubleshoot issues quickly in an automated way. You want to be able to reduce the time it takes to adjust to detect. You want to be able to scale and cover your entire enterprise across the globe, and to monitor that enterprise from a central location. Thank you very much.
ありがとうございました。